Good afternoon to you guys. I hope W5A is not difficult to find. The campus is basically surrounded by a ring road. So the buildings is actually inside the ring road. So think of it as a ring road of fire engine access way. So some tips on wayfinding to come into W5A. So my name is Chris. I'm a teacher from ABE and I teach in the diploma in architecture. So again, thank you for coming. Basically, a bit of intro as to what we are doing. This is the IDD computational sharing workshop that is actually spearheaded by BCA, by Dr. Tan and Pong. SP is actually co-organizing it. So the reason why we are starting this is because we are trying to get some ground-up enthusiasm for computational. And then with enough time, hopefully we can collate enough computational literature and then we can share it with the industry like yourself and apply it in your daily workflow at your workplace. So what's going to happen is that there will be 3 speakers. Basically, Quack from WUHAP will be speaking. He'll talk about some of the computational practices he's doing in his organization. Then followed by Autodesk, Mr. John Rivers, he will be doing that sharing as well. And then followed by Dennis, who will explain a bit on, who is our Deputy Director from ABE. He will basically share a bit on our Digital Building Innovation Center, exactly what we are doing. And then the 4th speaker, which is me, I will explain a bit more on what we are actually doing as a center. Alright, and then we'll run off with Wuhan, who will explain a bit on what they're going to do the next sharing. Alright, Quack from WUHAP will be our first speaker. Let's invite him to the floor.
Alright, thank you. Do I need to press F1? Hi everyone. My name is Quet. I'm from WUHAP. Currently, I'm working as a BIM manager. So my talk today is BIM computation with a view from the contractor. So this contains a presentation. After touching on what is our background, I will carry on with our approach and roadmap for BIM computation. It's followed by some example, and at the end, I will share our plan with the BIM computation. By the way, have you heard about WUHAP before? Yeah, I'm asking because some of my friends say I saw WUHAP brands in NTUC FairPrice. Are you selling chili sauce? No, actually we are not. We are main contractor established from 1927. So with over 90 years, we are the contractor doing some Singapore landmark project. So this is few project with WUHAP is the main contractor. Reflection, Intellect, Coral at Keppel Bay, Dididin, and Jewel at Changi Airport. So you can see the common themes of this project is come with very complex shape and design. I believe when architect design is already come, they already think using the formula and algorithms to design it. So as a builder, we also need to understand what is the formula and algorithms behind all this design. And that is where our BIM computation coming from. Just for joining force, we do this project about 10 years ago. So this is the time where our BIM as well as BIM computation start. you look at this shape of project, we cannot use the traditional way of construction and traditional method of coordination and soft drawing to construct it. For example, if you look at the roof ground, we have no choice. We have to use a 3D to do the coordination, and later on we also cannot make use of 2D to transfer the setting up. The setting out of the roof ground, we're using the 3D coordinate from the model and using the robotic total station to shoot the setting out to site. Okay. Other than that, where our BIM computation coming from is, for me, I think there's no one solution or one software can fit all the purpose. Each software, each solution, I think they have their own strong point or their own limitation. So as a contractor, when we do the model, when we create the software, we need to find a way to make the work faster. Furthermore, I think when we create the model, a lot of work is repetitive. So if we know about scripting, we know about programming, I think our work can carry on faster. Okay. Here is our approach and roadmap with the BIM computation. We started in 2010. At the time, we don't know about scripting or programming yet, so we just come with very basic form of BIM parametric modeling. Followed by 2013, we start exploring the Grasshopper for Rhino to do some kind of scripting. In 2015, we are exploring application programming interface with API. And at the time, we also exploring Dynamo for our work. And currently, we're looking at some cloud computing, so as the Autodesk Force or Trimble Connect API. So for let you have more clear picture on what is our progression of BIM computation development, each milestone I will show you some example and more detail on what we do at the time. So this is very beginning at 2010. We was work on this project, the level project is designed by Zaha Hadid architect. It's come with a lot of complex shape and odd shape and non-regular form. For example, there's some high degree slanting, some twisting surface, for this part, it's a bay window come with a twisting surface, and one interesting here is a structure column. It's a structure element. Is besides slanting, is also twisting. Then furthermore, the section of the column is changing level by level. Another challenge of project is the backplate and bay window. So when we overlay the backplate, if you look at this, level by level, all the backplate come with different angle, size and shape. And the real challenge is when our construction manager say to speed up the construction, we have to do it by precast. And as you know, precast is maybe more suitable for those standardized repetitive elements. But how to do the precast if all elements is all different, come with different angle and shape? So what we do, at the time we just look at the parametric modeling. We model in the element. We consider all the precast collection, all the joint, all the reset. Then from that parametric modeling, we will extract into table. And in the table, our engineer will summary, grouping, analyze it, and optimize it. So our goal is, without changing much on the original design intent, with minimum deviation, but is help us better in construction. So we set, like for target, we set the dimension should not derivate more than 10 millimeter with design intent, and from there we will optimize in this table. Then after optimizing, we input back to the model to see what the effect after optimizing. And after that, we feel okay, and we send to our architect consultant for their review and approval. So for this particular project, at the end, I think, sorry, and one more, we also work quite close with our precast mold subcontractor to do the mold design and optimize the mold design. So end up even with many shape of the precast, but we managed to cast many precast with just using one precast mold. So at the time, in average, we can cast about 110 to 200 pieces of precast by just using one mold. And remember, almost of it come with different shape and size. Okay, so this is a nice milestone in 2013. We worked on this project named Coral at Capital Bay. It was designed by Daniel Lesbinsky. So these are the workflow. The software they use is Rhino. From mastering model from consultant, we will use that model to start do coordination. And after coordination more or less done, we will use it to process the fabrication model, followed by fabrication drawings and cutting list. So for these two steps, visual scripting will help a lot on this. It help us to speed up a lot on the modeling as well as produce a cutting list. We have over 17,000 pieces of the glass paneling and 81,000 pieces of aluminum panel. So I'm proud to say at the end of the project, none of it rejected or cannot install because of the drawing discrepancy or because of coordination error. So here's one example how we use scripting on that project. So as a roof here, we have a lot of lighting fiber optics. So our facade contractor need the setting up of this lighting, so they can drill the hole on the facade panel. And this work is done on overseas and shipped to Singapore. So we need to provide them that setting up. But the challenge is the lighting design intent come in 2D, not 3D. Then somehow this surface come in 3 dimensions. It's it's an odd-shaped surface. So actually our subcontractor did try to use 2D method to get out setting up, but later on they gave up because it takes months to produce the setting out. So what we do, this we use some kind of scripting. So the scripting will get the geometry from the Rhino model. The design intent of the lighting we will put in the Excel format, and the designer can further optimize, fine-tune the design by changing the parameter in the Excel file, and it will be captured, reflect in the model. this work means the fabrication work is done in overseas, so any wrong coordination will very costly because it takes months to fabricate and deliver to Singapore. Alright. So another example, as a basement of that project, we have a lot of aluminum fins. So we use the scripting to do some automation work for modeling or checking the requirement. For example, there's a minimum requirements, the gap between two fins, because for the connection at top and bottom of the fin, the minimum gap requirement between two fins is 65 mm. So we use, this time not the scripting, we use the Rhino.lab to do small program. So what the program do is, it will get through all the fin inside the model, and it gets the geometry, and inside the program we will find the nearest two fin next to the fin we want to check, and from there it will calculate the distance between two fins. If less than 65 mm, it will pop up the arrow or highlight it in the different color for you to know and adjust. Alright, so after 2013, in 2015, we start exploring Revit Dynamo, and as a sum, we also start looking at the API, the application programming interface for Revit and Tekla. So here I will show you some example of the usage of this. We use a script